Welcome to another math tutorials. In today's lesson we're going to take a look at estimating population proportion, and we're going to do it using point estimates and also a confidence interval. The problem we're going to take a look at is from Mario Triola's Elementary Statistics, 11th edition, and it's in section 7.2, page 341, it's number 32, titled Medical Malpractice. It says, an important issue facing Americans is the large number of medical malpractice lawsuits and the expenses that they generate. In a study of 1,228 randomly selected medical malpractice lawsuits, it is found that 856 of them were later dropped or dismissed. So they're giving us here sample data. There was a sample of 1,228, and it tells us how many of them were later dropped. So in our symbolic notation, these are n for sample size is 1,228, and x is 856, the number out of the sample who dropped, the number of cases that were dropped or dismissed. And the first question is, what is the best point estimate of the proportion of medical malpractice lawsuits that are dropped or dismissed? And anytime they ask you for the best point estimate, the best point estimate is always going to be it's going to be the sample version of the thing we're trying to estimate. So in this case, we're trying to estimate population proportion. So the best point estimate, and point, by the way, just means single number, the best one number guess we have. The best point estimate is the sample version of the same thing. So if I want to estimate a population proportion, then the best estimate is going to be, in our case, the sample proportion, okay, which we call p hat. Symbolically, it's p with a hat. That's the sample proportion. And it's defined to be x divided by n. It's the percent. It's the number that we count how many were dismissed, and we divide by the total. So you just take x over n from the problem. It was 856 cases were dropped or dismissed. Out of the total number of cases was 1,228. Okay, so that's p hat. That's our best point estimate, and we could make that a decimal if you'd like. Just divide 856 divided by 1,228, and you get about 0.697. Alright, so that's our best point estimate. Now that's always the easy part of this kind of problem, because all you really need to do is find that sample statistic. The real work is to do the second part, the confidence interval. And we're going to do it with a calculator, so that's going to save us a lot of time and effort. So let's go on to part B. Construct a 99% confidence interval estimate of the proportion of medical malpractice lawsuits that are dropped or dismissed. Okay, so for part B, we're going to want what's a 99% confidence interval for proportion. Okay, if it's a confidence interval for proportion, then on our calculator it's going to be what's called a 1PropZInt. That's a proportion. Prop tells you it's proportion, and we're doing an interval, a confidence interval. So on your calculator, to show you where it is, if you go to your calculator, you go to Stat, and you go to Tests. You can go right twice, or you can go left once, and come to the Tests menu. And if you look at for the 84 plus here, it's option number, it's down below. It's not on here. It's option number 9, if I recall. Here we go. Nope, option A, 1PropZInt. So that's what we want to do. So let's hit enter there to run the 1PropZInt, and then it prompts you for what you need. X and n, which we already have. Remember, x was 856, so we'll just type that in. Enter. And n is the sample size. It was 1,228. We were told the confidence level was 99, so put 0.99. And then that's really all there is to it. You just have to pick those things out of the problem and we're going to hit calculate, enter, and there we have it. And by the way, it gives you the p hat and the n as well. We already computed p hat for part A, but this calculator computes it here for you. And then there's the confidence interval. Okay, so that's the answer. We're going to write that down. That's our estimate for the actual proportion p. So let's write it out here. We're going to say, you could write it like the calculator does, 0.66329, and you can round it if you like. I'll just leave it, 0.73085. So many people will write it this way. And then some people prefer to state the parameter that we're estimating. So some people like to say instead that p, the actual proportion, is between 0.66329 and 0.73085. So this is a different way of writing out the same thing. It's completely personal preference. It doesn't really matter. Both of those are giving you the confidence interval estimate for the true population proportion. Okay, so what does it mean? Well, it means that we're trying to get an estimate for the actual proportion of all malpractice lawsuits that are dropped or dismissed. We took a sample to make an estimate, and out of the sample, we found about almost 70%, 69.7% here were dismissed, and we used that to construct an estimate for the actual population. Okay, so again, this was from a sample of 1228. 69.7% were dismissed or dropped. And then we use that to estimate the all medical malpractice lawsuits, what percent would be dropped. And this is what we came up with, this interval. And what we can say then is we're 99% confident that the true proportion of medical malpractice lawsuits that are dropped or dismissed is between these two numbers, between 66.3 and 73%. Okay, so we could write that out, 99% confident that the true proportion dismissed is between 66.3% and 73.1%. We'll put it that way. All right, and then let's go back to answer the last part of the question, part C. Let's pop the book back up. So part C says, does it appear that the majority of such suits are dropped or dismissed? Well, what does majority mean? Majority means over 50%. So does it appear that over 50% are dropped or dismissed? And yeah, we say it's between 66 and 73%. That's definitely an estimate that's saying it's over half. Okay, so that completes this problem. So keep that in mind when you're doing a confidence interval estimate for a population proportion. You use a 1PropZInt interval under stat tests on a TI-83 or 84 calculator, and then you just basically pick out the x, the n, and the confidence level, and the interval comes right out for you.